Intermediate Algebra Section 2.1 Graphs. It has often been said that a picture is worth 1,000 words. In mathematics, this is quite literally the case. Graphs are a compact means of displaying information and provide a visual approach to problem solving. On the number line, each point corresponds to a number. On a plane, as you see here, each point corresponds to an ordered pair of numbers. We use two perpendicular number lines called axes to identify points in this plane. The horizontal axis is most generally the x-axis. The vertical axis or number line is referred to as the y-axis. These two axes intersect at a point that we call the origin. So these axes intersecting at this point has a name called the origin. The variable x, as I said, is usually represented on the horizontal axis with the y being the vertical axis. So we often call such a plane, two-dimensional object, an xy coordinate system. To label a point on this xy coordinate system, we use a pair of numbers in the form of x, y. This is known as the coordinates. And let's take a look at graphing some points. For example, if we were going to graph the point 2, 3, the first value is our displacement on the x-axis, and the second value is our displacement on the y-axis at the same time. Starting with the x, we'll go over 2 in the positive direction. There's a 3 on the y, and where those two intersect, over 2 for the x, 3 for the y, is our point. Now, another piece of information of interest is where these points are located. The x and the y axis divide the plane into 4 regions called quadrants. And the first quadrant is always here in the upper right-hand corner, where both the x and the y coordinate, as we saw in this example, are positives. The numbering goes counterclockwise. We'll see that points that land in the second quadrant have negative x's and positive y's. Continuing on, down here in this region would be the third quadrant, and for a point to land in the third quadrant, we have to have a negative x and a negative y. And finally, our fourth quadrant is here in the bottom right-hand corner, and for a point to fall in the fourth quadrant, we have a positive x with a negative y. So let's look at a couple more points. For example, if we had the point 4, negative 2. Where is the point and which quadrant is it located? So we have a positive 4, always starting with the x value first, and a displacement negative on the y-axis. So we'll drop down 2 points, and I'm right there in the midst of the G on the origin. What quadrant is this point landing in? It is in the fourth quadrant. And backing up, what quadrant is 2, 3 in? It's here in the upper right-hand quadrant, so it would be in the first quadrant. The point negative 1, negative 5 is located in which quadrant? Well, looking at the x value, it's negative 1, along with a displacement down or in the negative direction 5 on the y. So we'll go down 1, 2, 3, 4, 5. So here is the point, negative 1, negative 5. It's in the third quadrant, and as we see, both the x and the y are negative, so it's consistent with what we would expect. Let's take a look at this point, 0, 6. 0 is the value for the x, which means there's no displacement in the x direction. However, there is a displacement of 6 in the y, and as it turns out, this lands on the y-axis. It is in none of the quadrants for that matter. So it ends up being just simply a value that lands on the y-axis. Another point, if we had -2, 5, if we were to graph that, -2 in the x direction, we're going to the left of the origin, and a +5, which is going to place us here. Analyzing this point, we have a -x and a positive y value. That's consistent with second quadrant, and after graphing it, we can clearly see it's in the second quadrant. If you were asked what are the coordinates of the origin, the origin, as I earlier stated, is the name we give for the intersection of the x and the y. For a point to be at the origin, there is no displacement in the x direction or in the y, and so the origin would have the coordinates 0, 0. When we graph, there are times when we need to pick an appropriate scale, and you may see a problem like this in this section. The problem states, from the given choices, select the most appropriate grid dimensions and axis scale to plot the following points. So -64, 8, the point 12, 5, and the point -21, -6. It says, note all grids are 10 squares wide by 10 squares tall. And if we just look at the variables here, we have the smallest x of -64 to a high of 12. Our y values are going from a low of -6 to a high of 8. So let's look at our choices. They're asking for the first one here, that the x-axis run from -70 to 70. Well, we need to go at least to -64, so that seems reasonable. But to go to 70, since our highest value is 12, may be a little overstated. And it tells us with a scale of 14, so we would be fine with our scale of 10 by 10. But the y-axis from 0 to 10 is not going to be satisfactory because we need to include a negative value on the y-axis. So A is off our radar. Next, the x-axis runs from -70, that's good, to 30, maybe a little much, but let's hold on. And it has a scale of 10, which would work fine on our 10 by 10. The y-axis is from, in a poor line carriage here, -10 to +10 is going to accommodate our values. So this is looking pretty good. But is there something better? Reading through the choices, the last option we have is a -80 to 20. Well, the -80 is a little far off, but 20 is closer to our 12. That looks pretty good. And the y-axis is running from, and again, bad break in our line, a -80 to a 20, which is definitely, it includes our values, -6 to 8, but it's much more extreme than the previous choice in B, running from a -10 to a +10. So we're going to cancel C, although it would take care of our values. The best answer is going to be B, to represent these points that we need to graph.